Contactors and relays. You're going to find a contactor and relay in every piece of HVAC equipment that you run into, and they're sometimes confusing and hard to troubleshoot and understand when you're looking at the schematic diagrams. So we're going to go through them step by step. Contactors and relays are very similar to each other. They operate on the same principles. They're electrically controlled switches, the difference being that contactors have a larger load capacity, can carry higher voltages and current, and then your relays are for smaller loads and current. So compressors and big condenser fan motors are usually run by a contactor. Your indoor fan motor will be run by some type of relay such as this. So this is the schematic symbol for the contactor and for a relay. And when you're talking about contactors and relays, you have a contactor coil. This coil is what energizes and opens and closes the switches on the contactor and relay. So these are two common schematic symbols for a contactor coil. If a 24 volt signal is applied to these coils, what happens is it produces a magnetic field that switches the contactor opened and closed. So that is the control coil there. So you'll find a round schematic symbol. Sometimes it'll have a C on the inside. It'll have this symbol right here that represents a coil, and there are some manufacturers that have this little lightning bolt zigzag like this to represent the coil. All three of these right here represent the coil that energizes the relay. Now there's two parts to a relay and a contactor. The coil that has voltage applies and energizes it, and then there are the contacts. The schematic symbols for the contacts of a relay or contactor are these right up here. Now you have the first set is normally open contacts. They'll be designated by NO, and then you have normally closed contacts designated by NC. So what these schematic symbols tell you is that with no power applied to the coil of the contactor or relay, the normally open contacts are open, so no voltage or current will pass through that contact. The normally closed contact is just that, it's closed. It allows current to pass through and voltage to pass through the normally closed contact. Once these coils are energized by the control voltage, which again is usually 24 volts, the normally open contact switches to normally closed, and the normally closed contact now becomes open. And let me restate that. Once the control voltage is applied to the coil, the normally open contact is closed and the normally closed contact is open. So they reverse themselves, so that way you can switch on and off certain components by applying or removing voltage from the contactor or relay coils. Let's take a look at the inner view of a relay, and we're going to compare it to the schematic symbols that we just talked about. Alright, so the first thing we'll take a look at is the coil part of the relay, and that's right here, and it's just a coil of wire around a core. And when voltage is applied, the current that goes through this coil creates a magnetic field, and it opens and closes the contacts. So it'll close it using a magnetic field, and then there's springs that will spring it back once the voltage is removed from the coil and that magnetic field is no longer present. So this coil and this connection right here, and there's another one that is the same on the other side of the coil, is represented by this symbol here, or this symbol here, or that one symbol that has that little zigzag such as this. Now let's take a look at the contacts. Let's look at the normally open contact first. Remember, when no power is applied to these contactor coils, it is a normally open connection, so no voltage or current will pass through. And that is represented by this part right here. If we have a wire attached to this terminal of the relay and there is voltage applied to that terminal of the relay, this contact right here is open. There's a space between this part here and this part here, and that voltage and current has nowhere to go, so it's just a dead end. And that's what we see represented right here. So that voltage and current comes up to that open contact and dead ends. Now we'll take a look at the normally closed contact. So if we have a wire attached to this terminal, that voltage and current comes up through the bus, through the normally closed contact. Remember, no voltage is applied over here to the coil, and it works its way through and out this side of the relay. So remember, we talked about the contactor and the contacts being normally open and normally closed, but when we apply power to the contactor coil, the normally open contact closes and the normally closed contact now goes into the open position. So let's see how that works. So once again, this is our normally open contact. We have a wire connected to it. When we apply power to the coil, this magnetic field pulls this armature down and this contact now closes, and it passes the voltage and current through that contact, through the bus bar, and then to this terminal right here. The voltage and current that is attached to this side of the contact, normally closed, is now open, and there is a gap between these contacts right here, and that dead ends your voltage so that it doesn't pass through to the other side of the relay. Alright, now the difficult part about contactors and relays is deciphering them on a schematic diagram. So on the left here we have a contactor, and over here we have a schematic diagram for the condensing unit of a Lennox heat pump system. And here's where things start to get a little confusing and where you really need to look and think about this. So we have the contactor basically has, and relays have a couple different parts. Remember, we talked about that coil that energizes the contacts. Well, the voltage that is applied to this coil is applied on these two outer terminals right here. And if you look at the schematic diagram, you can see that there's that schematic symbol I talked about right here, the little zigzag. That is representative of the coil that is in this contactor right here. Now physically on a relay and a contactor, everything is in one piece, but on a schematic symbol, if you look at this, you only see the coil that energizes the relay. Now where are the contacts? Well, you're going to have to search through the schematic diagram to find the contact parts that you see over here and here. And this is common for all relays and contactors on schematic diagrams. So here's our coil. Now what about the contact parts? Well, that's represented over here. As you can see, that's a normally open contact, and it does say compressor contact. So this symbol up here represents this part of the contactor. And then it just so happens on this contactor there's a straight through bus bar, so this voltage is always applied through this bus bar. That's a straight through shot, and it's all the way down here at the bottom of the schematic symbol. So what we end up with is the coil is here, the normally open contact is here, and the straight through contact is here. It's in three different places on the schematic symbol, yet it is only represented by one. It only represents one component in your air conditioning system. So if you have a contactor or a relay in a system, you need to remember that the coil and the contacts are going to be in different locations. The reason that they have them in different locations is because normally your control voltage for the coil is low voltage, or 24 volts, and the voltage that is passed through to the loads is usually 120 or 240, and if you go commercial, you'll get up to 480 as well. So what these contacts and relays do is they allow low voltage controls to control large loads with high voltage and high current. Okay, so that's it for contactors, relays, and schematic diagrams. If you have any questions, post them in the forum, shoot me an email. If you're not one of my students, I'll be more than happy to answer any of your questions as well. You can go to www.hvactrainingsolutions.net if you want more information on online air conditioning training.